Let's have a look at one more question, which is based on finding the terms. If the second term of an AP is 13 and fifth term is 25, what is its seventh term? So now you don't know the sequence here. You don't know the arithmetic progression. You just know that second term has been given to you. Fifth term has been given to you. Second term is represented as A2. Okay. Second term is 13. By studying the general rule of arithmetic progression, I know any term is represented by writing it as the first term plus one less time the common difference. One less time. Any term of an arithmetic sequence is represented by first term added to the difference multiplied one less time than the position. So second term, to reach the second term, I'll be adding the difference one time. So 2 minus 1, it's 1. I'll write down A plus D equals to 13. I get my first equation in terms of A and D. Similarly, fifth term has been given to you as 25. Now you can be quick with applying the general rule. To reach the fifth term, I'll be adding the difference 4 times. So when you do so, you get the second equation, A plus 4D is 25. This is the general format of all arithmetic progression questions. You know, they'll not give the whole AP. They'll just give you two of the terms, any two of the terms. If you ever come up in this scenario where you have two terms of the sequence given and you have to find something else, you'll always end up getting two equations where you have two variables. Okay, you have your first term missing, you have your common difference missing. So you got your two equations. When two equations are there, two unknowns are there, you solve them by the concept of linear equations in two variables, or you also call them simultaneous equations. Why? Because you have two variables missing, and to solve for two variables, you need two equations. Okay, or else you will not be able to find the individual values. The quickest way I can think about solving the two equations together is by eliminating the common term. I see that both of my sequences have A and A appeared, and I can get rid of that A by simply subtracting the two equations. So I'm going to subtract the two equations. To subtract, I suggest just flip the sign for the second expression or the second equation. Here we have an equation. So A minus A is 0. The sign I have written in this circle, that is what the sign we are to consider. So D minus 4D. D minus 4D is minus 3D. 13 minus 25 is minus 12. Because you have minus both sides, you can get rid of it like this and divide both sides by 3. If you do so, 12 divided by 3 is 4. I got the common difference as 4. Once you have the common difference, don't forget that our equations were in two variables, so you need the value of A. To find the value of A, use any one of the equation. I would prioritize to use an easy one. A plus D is 13, so if I know the value of D is 4, A plus 4 has to be 13, giving me the value of A as 13 minus 4, which is 9. So A equals to 9, D is equal to 4. I got the two main variables that can help me find any term of the sequence now. So what is its seventh term? Question was all asking me about the seventh term. So to find the seventh term, I'll write, I know seventh term is reached from the first term by adding the difference 6 times. So if you'll do this directly, you have the value of A as 9 and the common difference we got was 4. So 9 plus 24. The answer has to be 43.